Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to do a practice free response question. So let's jump in. Golf balls must meet a set of 5 standards in order to be used in professional tournaments. One of these standards is distance traveled. When a ball is hit by a mechanical device, iron Byron, with a 10-degree angle of launch, a backspin of 42 revolutions per second, and a ball velocity of 235 feet per second, the distance the ball travels may not exceed 291.2 yards. Manufacturers want to develop balls that will travel as close to the 291.2 yards as possible without exceeding that distance. A particular manufacturer has determined that the distance traveled for the balls it produces are normally distributed, with a standard deviation of 2.8 yards. This manufacturer has a new process that allows it to set the mean distance the ball will travel. The first thing I notice after reading the problem is that there's a lot of extra information. The important parts are that the distribution of distances are normally distributed, and it has a standard deviation of 2.8 yards. The other thing we have to keep in mind is that they do not want the ball to travel more than 291.2 yards. So let's jump into part A. If the manufacturer sets the mean distance traveled to be equal to 288 yards, what is the probability that a ball that is randomly selected for testing will travel too far? Since we are told in the problem that the distance traveled is normally distributed, we can draw a normal curve to model this distribution. We're told the mean is 288 yards. We can mark that. Sorry for my bad handwriting here. And they want to know the proportion or the probability that a ball will travel too far. Well, too far is cut off at 291.2 yards. So we want to know what proportion of balls travel further than that. We can find that by going to our calculator and using normal CDF. On our calculator, we'll hit second vars to get to the distributions menu and then go down to normal CDF. The lower boundary on our curve was the 291.2 yards. The upper just needs to be something really big, like 1,000. The mean was 288, and the standard deviation was 2.8 yards. If we hit enter and paste here, we get the answer is 0.1265. This tells us that the probability of one of their golf balls traveling beyond 291.2 yards is about 12.6 or 12.7%. We're going to skip part B and jump into part C now. If the manufacturer wants to be 99% certain that a randomly selected ball will not exceed the maximum distance of 291.2 yards, what is the largest mean that can be used in the manufacturing process? The distribution is still normally distributed, so we can draw a curve here. We do not know the mean anymore, so this is what we're going to be looking for, is this mu right here. The problem tells us that at 291.2, the manufacturer wants the area to the left of it, this area here in blue, to be 99% or 0.99. We are unable to use normal CDF or InvNorm to solve this at the moment because we don't have the mean. So we're going to rely on z-scores. We know that a z-score is equal to the data value minus the mean divided by the standard deviation. We know that the data value is 291.2. We don't know the mean, but we do know the standard deviation is 2.8. And using InvNorm on our calculator, we can find the z-score that corresponds to 99% of the distribution being to the left. We would get 2.3263. If we took a minute and solved out this equation, we would find that the mean is equal to 284.6864. Again, sorry for my handwriting there. It's a little bit on the messy side. So if the manufacturer set the mean distance of its golf balls to 284.6864, 99% of the golf balls would not exceed this maximum distance of 291.2. I hope you found today's video helpful. I'll leave you with this quote. Thank you for joining us, and have a great day.